Our focus standard for this lesson comes from Grade 7, Number Systems, Standard 1. Apply and extend previous understandings of addition to subtract integers. The topic for this lesson is the last in our adding and subtracting integers, and it is called Subtracting Integers Shortcut. Our essential question for this lesson is, how can we use inverse operations to rewrite equivalent addition problems for any subtraction problem? So please take a moment pausing the video if you need to copy down the topic and essential question into your header, along with today's date, sub the question column and the note column, and resume the video when you're ready to begin. Alright, so as I mentioned in the intro, this is the last video lesson for our adding and subtracting unit. And I'm going to start it off with a key reminder. We've known this ever since we started learning about adding and subtracting, which are the first two operations we teach students. And we know that they're inverse operations, meaning they do the opposite thing. And so because of this fact about addition and subtraction, we can write for every subtraction problem, there's an equivalent addition problem, and vice versa. But this is a nice thing as we are learning to master working with integers and adding and subtracting integers, because sometimes I have found that addition comes a little more instinctually for students when we start adding and adding negative numbers. And so it's nice to know that you could turn any subtraction problem into an addition problem and then follow what you know about that to get the correct answer. So the shortcut phrase that we use is keep, change, change. We're going to keep the first integer in the problem, then we're going to change it to an addition problem, and we'll change the sign of the second integer. So this changing is making us use the inverse operation, the opposite thing. So the opposite of subtracting is to change it to addition, and then to add the opposite. And so we change the sign. So we're adding the opposite to create an equivalent problem. So keep, change, change. We're going to look at 4 example problems to practice this. Let's look at our first one. So in our first example here, we have 8 subtract 3. Now I start with this because this is a problem that you learn to do in elementary school. However, sometimes when we start working with integers, we kind of forget or are unsure of what we already knew. So most of us are going to know that if I take 8 and I subtract 3, I'm going to land at 5, right? Let's take a look at what it would be like to apply the shortcut. Well, we would keep the positive 8, change subtraction to addition, and change it from a positive 3 to a negative 3. Now think about that answer. 8 plus a negative 3. You would keep the 8 and go towards the negatives 3 spaces, and the answer would be 5 as well. So starting with something we know very comfortably with subtraction, we can rewrite it as an addition problem. We change it to addition and change the sign in the second number. Keep, change, change. Let's try the next one. Here's our second example. -4 subtract 7. Now you could use the chip model, you could think about this on a number line. And with this shortcut, I don't want you to forget how to do that. I just want to show you that this will also work. So think about where you would be. We would be at -4, facing the positives, but walking the opposite direction. So we go -7 spaces. And -4 subtract 7 is going to be -11. But you can also think about it this way. -4, keeping that the same, change subtraction to addition, and the positive 7 to -7. Keep, change, change. Well, now we know when we are adding 2 negatives that the answer is going to be negative. We know that 4 plus 7 is 11, so the answer must be -11. Alright, Let's take a look at the third example. Here, we're starting with positive 6 and subtracting a negative 8. So you can try and figure that out. Or maybe you want to think about it as addition. Keep the first number, change it from subtraction to addition, and change it from a negative 8 to a positive 8. Well, it's really easy to see here that 6 plus 8 is 14. And if we start at 6, and we face the negatives, and walk 8 spaces backwards, we're also going to land at positive 14. So 6 minus negative 8 is 14, and 6 plus 8 is 14. So keep, change, change help us write a simpler problem that we know is equivalent. Let's take a look at our last one. For our last example, we have negative 3 subtract negative 7. So again, you could use what you know about the number line. Or perhaps it's easier to think about it as the opposite addition problem. Keep the first number, change it from subtraction to addition, and change the sign of the 7 from negative to positive. Negative 3 plus 7. Well, negative 3 plus 7, we know we would start at negative 3 and walk towards the positive 7 spaces as an addition problem. And we would land at 4. Well, same is true with this problem. If we start at negative 3, we face the negatives but walk backwards 7, we're going to cross over 0, and we're going to land at positive 4. It's for these last two problems that I really find this keep, change, change method really helpful. And there's one more thing. I will sometimes refer to these types of problems here where we see we're subtracting a negative, and in D we're also subtracting a negative. So I will sometimes also talk to my students about using the horseshoe method, which helps us see the keep, change, change really quickly, and that is we just draw an upside down horseshoe like this through the two negatives. So it makes this, the upward swing makes that look like an addition sign, and the downward swing changes that negative to a positive also, so we can think of it as 6 plus 8. And so again, we'll see that as the horseshoe method to help us remind us that this is an equivalent problem down here. And then same thing with D. We could see it say negative 3 subtract 7. We see that subtracting a negative. We've talked about it before in previous videos. Oh, it's more, we're actually doing the positive thing. So we can do that horseshoe method real quick. Draw it in. We draw it nicer than that. We can see that it looks like a plus sign that changes the negative 7 to positive and quickly shows us this equivalent, or reminds us of this equivalent problem. And sometimes that's an easier thing. So again, all this I will sometimes refer to as the horseshoe method. Just that it's still that keep, change, change, but if you're subtracting a negative using this horseshoe, what I refer to as the horseshoe method, may also be helpful. So that's going to conclude our video today on subtracting integer shortcuts. I hope it was helpful, and come ready to continue to work with adding and subtracting integers in class.